In this video, I'll demonstrate how to solve for an angle, I'll call that angle theta, when we're in degree mode, and there's going to be two possible answers. That's because there are two places between, let's specify here too, that theta is going to be between or equal to 0 and 360 degrees. And there's going to be two places on any sine wave or any sine rotation where sine is positive. We'll draw a sketch of how that works to illustrate. So here's your x and y axis, make sure to label them, and then think, where is sine positive? Well, start with your initial arm, make it clear to the reader. There's an initial rotation starting always on the x-axis, rotating counterclockwise, and ending up in at least the first quadrant, because that's where everything's positive. Let's draw the cast rule and remind ourselves, in this quadrant cosine's positive, in this quadrant everything's positive, in this quadrant sine's positive, and in this quadrant tan is positive. So everything's positive in quadrant 1. That's going to be one of our rotations, theta 1. And in this quadrant 2, sine is also positive. Quadrant 1 and quadrant 2 are the quadrants where sine is positive. So show those rotations, theta 1 and theta 2. And then I'll call these little related acute angles. That's the angle these rotations make with the x-axis. I give them little x's to symbolize the fact I want to know the angle right inside here that each rotation makes with the x-axis. So step 1 is always draw the sketch and label everything correctly. When you're done that, step 2 is find the related acute angle. That is, I want to solve for the positive version of my question, which is in any case positive, but if it were negative, still here I'd be solving positive, and say, where is sine x equal to a third? Well, that's wherever x is going to be the inverse of sine or reverse of sine. And I'm going to use my calculator in degree mode, make sure you're in degree mode, to solve this equation. So I'll go second sine, brackets, 1 divided by 3, close the brackets, and I get x is approximately, let's round to the nearest degree, I think, 19 degrees. Step 1, drew the diagram. Step 2, solve for one of the possible answers. But remember, there were two possibilities, here or here. So the last 2 marks in this question come from actually calculating the thetas. This first theta, the first rotation, was just go up exactly what x was. Whatever this little angle was in here, that's the angle you rotate. So theta 1 just equals x. In other words, theta 1 is really 19 degrees. But for theta 2, we have to do a bit more work. That is, we have to recognize that in quadrant 2, your rotation, this theta 2 rotation, went around as much as the whole way, 180 degrees, except come back x. Or another way to think about it, you cover this whole rotation except for x. You do 180 degrees around except whatever that rotation was in there. So theta 2 is 180, take away 19, which is 161 degrees. So we have two possible answers. Where is sine theta equal to a third at approximately 19 degrees or at approximately 161 degrees?